Well, hello everybody, and welcome to another OpenShift Commons briefing today. We have Karl Wehden from Lightbend, who's going to give us a talk about the Lightbend platform and delivering transformative reactive systems on OpenShift. And that's a big topic and an interesting one. So I'm going to let Karl introduce himself and get the talk and demo underway. You can answer or ask questions in the chat. And we'll have live Q&A at the end of his talk and demonstration. And I will try and answer any questions, but doubtful. So if there are other people on from Lightbend, they may answer them in the chat as well. But let's get going, Karl, because there's a lot to cover.
Thanks, Diane. So today we're going to talk a little bit about exactly that, reactive systems on OpenShift. Just a little bit of a word about Lightbend itself. Lightbend is the company behind a couple open source frameworks that are relevant to this topic. Akka, which is distributed runtime, Play, which is a web services focused microservices framework, and Lagom, which is a little bit more of an advanced microservices framework that covers event sourcing and CQRS in the reactive space. And we're also, not insignificant, the company behind the Scala programming language. Lightbend Platform, which is our commercial offering, builds on these open source projects to create application to allow people to build applications on this platform, and includes what you need to help drive this. And more importantly, it's deployed on OpenShift. It's used for a lot of heavily transformational projects at a variety of our customers. Everything from improving financial processes to increasing customer experience to rebuilding core elements of a financial services organization. And you'll see a ton of different perspectives and options in terms of how that works. So the core aspects of Lightbend Platform are really, one, the distributed systems architecture that's expressed through the use of things like Akka, Lagom, and Play. That allows you to build event-driven microservices that are highly scalable. And we introduce a variety of tools on top of that that help with things like real-time streaming and machine learning. And I'll talk a little bit about that as well. The important part of this process is the operational side of the house, and that's really where Lightbend's end-to-end monitoring and management tool sets give you the capacity to really understand what's going on inside of a distributed system. We also offer products for security and risk mitigation, things like support for GPRS, right to forget, in distributed systems, static analysis of Scala code, and the like in that area. So what is a Lightbend platform? The Lightbend platform is, as I mentioned, a combination of these things. And we see these in a couple categories that are important. One, reactive microservices. It's important to note that when I say reactive, I'm really referring to what I think of as a reactive system. What is a reactive system versus reactive programming, you might ask? It's the idea that you're not simply looking for asynchronous call stacks to express your programming logic. You're expecting a system to be elastic, scalable, and resilient as a whole. And I'll give you some examples of that later. On the streaming engines and machine learning side of the house, we support a variety of different open source frameworks, Akka Streams, Apache Spark, Apache Flink, Apache Kafka, for example, because in many cases, using one or just one of these isn't going to fit the job that you're planning to do. And then we do a ton of work on the machine learning side with obviously Spark, but also do a bit of work with things like TensorFlow and Kubeflow, and a variety of others. We think in this type of platform, especially because you're trying to pull together both streaming and microservices, Kafka plays a critical role as a data backplane for things like event sourcing and data distribution. We run on OpenShift, I think that's clear, and we really work with a wide variety of storage options in terms of how that works. Lightbend Console gives you, as I mentioned before, the intelligent managing and monitoring tool sets and a degree of integration and security that's relevant to these build scenarios. But most importantly, in the central block, there's something that we're introducing now which we're quite excited about, called Lightbend Pipelines. So what is Lightbend Pipelines? What do we use this for ultimately? The Lightbend platform is good for developing stable services and development of streaming pipelines, but combining these two things is often difficult. And I'll talk about what that looks like now. So here's a quick example of what a hand-coded stream-based processing pipeline might look like. In this case, we happen to be pulling in a set of documents and ingesting them, enhancing them, doing some aggregation, potentially scoring them against some models in this case. And there's a variety of steps here. Lots of moving parts is really the way to look at it. Manually managing things like the topics, the serialization, potentially the schema, and then handcrafting and deploying these things over a period of time, especially as these jobs tend to grow in complexity, it can be difficult. And what you get out of this type of deployment is highly scalable and powerful, but the operational overhead can sometimes be onerous. So why Lightbend Pipelines to solve this problem? Pipelines gives you the capacity to address some of the complexity that's here. Managing and composing these applications are tough. Working with multiple frameworks and marshaling between them can be tough. Managing state and checkpointing, often, some of these processors work or don't work, and you need to be resilient enough to be able to handle that. And then evolving applications over time can be difficult. And especially if you're introducing things like machine learning models and exposing things as a microservice. So what does pipelines offer? Pipelines really starts to introduce some critical concepts here that allow us to simplify this process. We introduced this concept of what we call a streamlet, which is literally the implementation of the actual stream processing logic and where we'd like to focus most of the effort of development in this case. Streamlets have different shapes, that are typical to a directed acyclic graph or DAG, including ingress, egress, fan in, fan out, processors and views. This gives you a pretty comprehensive toolkit to work with in terms of developing these streamlets. And these streamlets can be multimodal, so you can perform some enhancement in something like Akka Streams, and then perform an aggregation in Spark if it's warranted. But there's a variety of ways to do that. And then importantly, each streamlet is strongly typed with inlet and outlet schemas. What this means is that if those schemas match, connecting up streamlets in what we call a blueprint is a simple configuration process rather than a marshalling exercise and a management of schemas. So to apply that to our example, a schema in this case, in that flow might be the definition of the documents that we're ingesting. The ingress, in this case, from a streamlet perspective, would be something that would process those documents and push them onto an Akka Streams flow, and then a variety of streamlets would perform the appropriate aggregations or operations. And then an egress is a simple process of creating an outbound connection to the pipeline itself. And that can be, called by a variety of things, including other services, more importantly. So what does this look like from a developer experience perspective? What we look at here is a set of source code that is specifically the implementation and the streamlets and a blueprint. This allows us to tie those two things together. We take those and we push them as Docker images onto an OpenShift cluster. And then we deploy that to OpenShift itself. And that's all it is. The really notable part about this is the fact that we eliminate a lot of the complexity of handling marshaling or management in these cases. So I'm going to show you what this looks like real quick. Ultimately, that's part of it. So I'm going to jump over to Lightbend console. Lightbend console really briefly is how we look into the distributed systems that are part of this process, that are part of the system. This is running on an OpenShift cluster on our side. So I'm going to select pipelines here. And we have put together a quick example of a flow using both Akka Streams and Red Hat's Red Hat Decision Manager or Drools. And what this this application does is processes a set of, basically a volatility stream of market data about a set of options, and then evaluates them against a set of risk metrics that are commonly called Greeks. Those give us a view of what that looks like. And as I mentioned, this flow is expressed in this graph. So what does this graph look like from a code perspective? One is described in this very simple blueprint, which gives you the capacity to declare a set of processors or streamlets, and then simply wire them up by referencing a connection to the inlets and outlets that correspond in the connection section of this blueprint. An example of a processor itself is this quick processor, which is simply passing the data in and scoring it against a set of Joule's rule sets that are part of that. And as you can see, there's not a lot of boilerplate here. We're not setting up an interpretation of structure. This is all effectively described in the definitions that are there. So you can really focus on the stream processing implementation rather than having to work through the boilerplate in many cases. So this processor right now is chewing through a good number of requests. Over time, we're able to monitor things like consumer lag and Kafka topic overview in many cases, and that gives us a strong view into what's happening within the application without necessarily having to wire it up. And then in this example, like as I mentioned, we're using the VIX data to drive an understanding of risk, and we're using that risk to provide inputs for an appropriate rules-based system that's scoring whether or not the change in options position should result in a buy or a sell over time. Now, the great part of this is that because this is using Akka, and Akka Streams is essentially a DSL built on top of Akka, this is imminently distributable. It gives you the capacity to continue to add resources to the cluster, and you can continue to scale the operation over a period of time. This is just a quick example of what that looks like overall. Now, this type of flow is just one example of what you can do with something. You could take that rules-based processor that I've showed you earlier, introduce, say, a machine learning or deep learning model that might better reflect the type of data that you're doing in this case. You might be evaluating risk on a set of transactions for accounts. You might be looking at the relative performance of an underlying system. You might be evaluating the likelihood to fail for a piece of infrastructure or other components. But the reality is that you can very quickly pull together a set of source data, the ability to process it, and then the ability to pass it on via an egress or essentially an HTTP service to a downstream system. So you can use that information directly in an actionable format. In this case, we're just passing it to a Grafana dashboard for purposes of visualization. So that's a quick example of what you would use pipelines for. I think one of the questions you probably have is, why am I using Akka Streams to do this? Well, Akka Streams is a DSL on top of Akka, and I really wanted to give you a good sense of what Akka is good at in this context as well. So just a quick set of words about Akka itself. Akka is a distributed framework that uses the actor model to create a set of stateful services. So the runtime and the data coexist in memory and is accessed by generating messages. And those messages are passed between actors, which you can think of as stateful building blocks. The messages are passed asynchronously, so you avoid a lot of the blocking that you might normally see in these situations. And actors are actually part of what we think of as supervision hierarchies. So actors can create other actors can form supervision hierarchies to describe those things. And all this is core to the Akka library, and it's expressed in Akka Streams as a DSL for stream processing, but it's also used in many cases to build complex services. And finally, actors are lightweight and don't hold threads. They actually share thread space through a set of dispatchers that allow for very efficient use of compute. So what does this look like? is really the big question. Um, an Akka cluster underneath these scenarios can basically be described as a way to distribute work in many cases. And we'll take a look at that real quick here. As this comes up. But the fundamental idea is that of course it's having some fun here.
The beauty of a live demo.
Of course. There we go. So this is a quick visualization of a running Akka cluster. When an Akka cluster starts, it's started by essentially a member singleton, very similar to a lot of the stateful set-oriented deployments that you would see. What you're looking at here is essentially a set of pods, a single starter member singleton, a member, and an HTTP endpoint that happens to be serving this UI. Outside of those pods running on OpenShift, you're seeing a set of shards. Now, shards are essentially natural distributions of data and work within a cluster that may correspond to multiple pods, but generally you've got an option in terms of how it would run. And then within those shards, there are what we think of as entities, which are components of data that are being acted on in this case. In this scenario, we're just passing information back and forth between the different actors that are essentially part of those shards to make a non-converging distribution so that the visualization looks good. But why is this powerful and interesting? Part of this story is that essentially at any point in time there might be events or scenarios where you would lose a member. So I'm going to click on this member and it's actually going to shut the pot down that has all of these shards attached to it. And what that will do is trigger an event in the supervisory model to say, hey, I need a better coverage. And in fact, there you go. You can see the cluster has just resharded, and essentially the two remaining nodes have taken on the responsibility of an additional set of the cluster itself, so that the representative function is there. Now, because we're on OpenShift and I've requested 3 running pods, it actually reinstantiated and spun up another pod, and you can see that as that pod becomes available, you have again a redistribution event where the shards and the component entities that are referenced by the shards start to redistribute it across the other across the additional node. If I add a node, for example, here as well, you can say, okay, in this kind of situation, because we're only on 3 nodes, we might be experiencing potentially some lag or not, depending on what's going on, or we're just looking to better distribute workload. So I've added another pod. As soon as that comes up, it'll start participating in the cluster itself, and there you go, and resharding the entities and the shards that correspond to it. The power of something like pipelines using Akka Streams, or frankly, a set of microservices developed on top of Akka with this case, gives you the ability to even out and distribute processing naturally within the imminently distributed message-based system in this case, and gives you a clear view of what that would look like and how it would work. So I just wanted to make sure that, underneath the covers, it was clear that we're using the Akka library to essentially provide the type of distribution and throughput that you're seeing in the pipelines example I've given you in this case.
Hi, I had a quick question. How many pods were you running in that previous visualization?
This one?
Yeah.
Yeah, so I had 3 and I went to 4.
Okay. And I'm assuming the visualization itself is done on D3, but is there a REST endpoint that exposes that through an Akka cluster, all that information of shards as well as the pods?
So the endpoint is simply an Akka HTTP endpoint that we're exposing directly from the cluster.
Okay.
That's being consumed at that point. At the end of this, I'll actually share the repo that this came from as well.
Okay. Cool. Thanks.
but we have just a quick JavaScript visualization library that's pulling data from that Akka HTTP endpoint that's running on that guy right there. So again, it's a good way to at least visualize the structure of a pod to a shard to an entity in this case. And then kind of the next step behind this is, because this is a fully asynchronous scenario, and we've got this level of redundancy and resilience in a cluster, you can add to this the idea that you might want to write back down to a running database inside of that, Couchbase, Cassandra, Mongo, etc., and drive that. Now, one of the key elements of this type of system is that it's really focused on providing asynchronicity and response time to make sure your applications are as responsive as they need to be. But often it's put in a mode where it's eventually consistent, meaning you may perform the work directly in the Akka cluster itself, and then eventually write back to an event log or a persistent data store as part of that. And that helps with both perceived and real performance in applications as well. So what are we doing at Lightbend now? In many ways, we're looking at this as a good combination of two things. We've really been focused up to this point on what I would think of as code-driven development. Putting together Akka as a library and establishing that format. And from an operations perspective, typically you're deploying a set of built containers to OpenShift or other Kubernetes distros. As part of that, where we're going with things like pipelines is what I would think of as configuration-driven development, where you can simply write the implementation and wire that up in a blueprint. And we've automated the deployment of that tool set as part of that story. Where we're going right now is really visual configuration development, where you could potentially take an existing library of Streamlets in pipelines, wire them together coming out of the library based on the inlet and outlet strongly typed interfaces, and then deploy them and continually optimize them for performance. Today, Pipelines deploys as an operator on OpenShift, and we're continuing work to establish a variety of additional supporting operators within the Reactive stack today as well. We do a lot of work and contribute a ton to some of the Spark operators and Strimsy, the Kafka operator that Red Hat offers, as part of that story as well. And we're really pleased to continue to collaborate with folks on that overall. So that's what I wanted to show today, just to give you a couple examples of how you could simply and easily build both reactive and stream-based systems using Lightbend pipelines, and a little bit of a dip into what Akka is and how it works. I'm pretty excited to do it. And if you're interested in trying it, hit us up and we'll happily give you a spin on the platform from a demo. But just to recap, rather than having to do hand coding for these types of streaming applications, Pipelines gives you the ability to develop, compose, and operate streaming apps easily. You can pick the type of Streamlet or streaming engine implementation that works for you. This is done through an operator, so we have pretty solid automated provisioning and management of these jobs, and it lets you expose streaming data pipelines as microservices. And that's really an important point to kind of hit on here, which is analysis is good, but actionable intelligence that's included in downstream applications is even better in this case, and it's really there. So that's what I had today, Diane. I just wanted to see if there's any questions and what I can do to help.
Well, I think that was great. The other thing that I just put into the chat was the link to the how to deploy Kubeflow on Lightbend and installing all of that, and just to give people a link back out to your blog posts and all of that goodness. And it was quite interesting. On one of your very first slides, you had a list of all of the people or a number of your customers, and almost, if not all of them, were probably people that I've recognized from the OpenShift ecosystem, using OpenShift in different places. So it'll be interesting to see, get some feedback from some of them, and maybe get one of them to tell us about how they're using this in their efforts. The chat, if people have questions, I think Barat asked the one question that I saw come through. I'm looking to see if anyone else has any other questions. One here. The URL for the repo, if you could maybe pop over now to wherever that repo is and show us that, and that'll show up in the video.
Totally.
Afterwards. Yeah, it's always good. And I'm just curious if anybody, there's a bunch of people who are on, if anybody's already using Lightbend or Akka, that'd be interesting for me to know. There you go. Adam's added into the chat as well. Oh yeah, nice. Yeah, it's a great demo. I'm looking forward to seeing someone doing a demo of how they use it in production and what they've discovered. Would be a great next story to do with you as well, Karl.
Absolutely. Yeah, just a word on Kubeflow and a few of the other components. We do a lot of work to ensure that that these components and some of the frameworks they use are production ready. We support these or certify them on the platform, and thereby certifying them to run well on OpenShift. We're certainly working with a variety of teams, including Red Hat, Google, and the like, on these projects to make sure that things are flowing well and they're in format. So, that would be potentially an interesting follow-up as well. There was a couple links on the invite to blog posts for Kubeflow deployment and a few others that I think are very interesting as part of this. In summary, in many cases, I think combining streams and microservices effectively is hard because you have to be non-blocking, you have to be resilient, you have to have the type of core infrastructure that something like OpenShift provides. And in many cases, that's been very helpful for us as we continue this journey, primarily because it's an excellent complement to what I would think of as the application layer of scalability and resilience as part of that story. So we're really pleased to work with Red Hat and OpenShift, and thanks again, Diane, for the chance to present this.
Well, thank you for all your effort with Strimsy and all of the other operators as well. It's been really fun working with your team and learning more about this project and this product offering. So, and Manjo is talking in the chat about, he's deploying it now at some client projects. So hopefully we can get him to, once he's learned some lessons and found out some new insights, we can get him to do a talk on this as well, because I think it's one, the visuals are absolutely wonderful, but also I think it's a pretty powerful platform. So looking forward to learning more about it and hearing more from people who are using it in the future. Thank you all for joining us.